Welcome back. In this demo, we will launch a AKS cluster and scale it up and down to understand it from multiple aspects. Let's launch Cloud Shell from the Azure portal. Let's maximize this. First, I will create a resource group. AZ group create -L East US -N my resource group. Resource group has been created. Now let's launch a cluster with single node. The command is AZ AKS create --resource -group my resource group --name my AKS cluster --node -count 1. So this is going to be one node cluster. This command will take some time. So let's come back once the cluster is ready. Cluster is now ready. You can see the output here. Let's open another tab and see the cluster status from there. Click on Kubernetes service. Let's click on my AKS cluster. This is the cluster which we just provisioned. The cluster seems to be running. Click on node pools. I have a system node pool named as node pool 1. Provisioning status is succeeded. Power status is running. 1/1 means it has one worker node. Kubernetes version is 1.22.11. Node size is standard_ds2_v2 and the operating system is Linux. If you click on the node pool, you can see overview and nodes and configuration. Here are some options. All right, now let's head back to terminal and download the credentials and connect to the cluster. AZ AKS get credentials --resource group my resource group --name of the AKS cluster --override. Now I should be able to run kubectl get nodes command. It's working. I can see one node running as part of my cluster. Now let's see what are the system ports running into this cluster. I will run kubectl get ports -n cube -system -o wide. These are basically the system ports running as of now onto my cluster. And these ports are running on the nodes part of system node pool. You can see the node name here. Right, so these are all basically your controller running into your AKS cluster. Right, so all the system ports are supposed to run on system node pool. All right, now we are going to add one more system pool with AZ-AKS command. Let's do that. The command to add system node pool is AZ-AKS node pool add -g my resource group -n name of the system node pool, that is sys node pool here --cluster name of your AKS cluster, that is my AKS cluster --os -skew, that is Ubuntu --node -count. I mentioned one, so it is going to launch a system node pool with one worker node --mode system. So this is going to be a system node pool --node -taints. I'm going to add a taint also to this system node pool. This will prevent any application ports from accidentally killing system port, right? So it is always recommend to schedule your application port on user node pool and dedicated system node pool to only critical system ports. Adding node taint will prevent rogue application ports from accidentally killing system ports, and we are enforcing this behavior with node taint. Let's hit enter. This command will take a couple of minutes to create the node pool. We'll come back once the system node pool is ready. This is AKS Blade. Click on the node pools. I can see system node pool is there. This system node pool is having one worker node and it is in ready state. Mode is system, so that means that is a system node pool. And we have Kubernetes version 1.22.11. Node size is also mentioned, and we have operating system as Linux. Right, so everything seems to be working fine till this moment. Let's head back to terminal. Now we are going to add a user node pool. The command to add user node pool is AZ-AKS node pool add -g my resource group -n. User node pool is going to be the name of your user node pool --cluster -name my AKS cluster --os -skew. It is going to be Ubuntu and --node -count 1. That means the user node pool is going to have one worker node in it. This command will take some time. Let's come back once the user node pool is ready. Let's switch to the tab and see the user node pool status. As of now, I can see only two node pool 1 and system node pool. Let's click on refresh. I can see third node pool, that is user node pool 1/1 ready. So it is in running state. This time mode is user, That means this is user node pool, and we have Kubernetes version, node size, everything same. All right, now we have three node pools available: node pool 1, system node pool, and user node pool. You can verify the same using AKS show command. Let's go back to terminal, clear the screen, and let's run this command: AKS show hyphen resource hyphen group my resource group hyphen name my AKS cluster hyphen query agent pool profiles. You can see in the output there is a list. In this list we have first pool as node pool 1, and it has one worker node. We have second node pool named as system node pool with worker node 1. Similarly, we have third node pool named as user node pool with one worker node in it. So we can see the name of all the node pools and number of nodes in the node pool using AKS show command. Now we are going to scale the cluster to 2 worker nodes in the node pool, user node pool. Let's run this command: AKS scale hyphen resource hyphen group my resource group hyphen name my AKS cluster hyphen node hyphen count to hyphen node pool hyphen name user node pool. So this command is going to scale up number of node in the node pool, user node pool. It will take 2 to 3 minutes to complete. Let's come back once the node pool is scaled. The command is successful. Let's verify that from the AKS blade. Let's hit refresh. I can see 2/2. That means we have 2 worker node as part of user node pool. Now let's head back to terminal and run kubectl get nodes command. I can see there are 4 worker nodes running now. I have AKS-node pool 1, that is basically part of node pool 1. I have AKS-system node pool, that is part of system node pool. And I have 2 worker nodes part of user node pool. AKS-user node pool hyphen some random number, and we have VMSS 000 something, and then we have AKS hyphen user node pool hyphen some random number hyphen VMSS 00001. So that means we have 2 worker node part of user node pool. We are able to successfully scale up user node pool. Now let's scale it back to 1. The command is again the same. The only thing which we will change in the command is I will mention node count as 1. So this command is going to terminate one of the worker node. The command is now successful. Let's verify that using kubectl get nodes command. Kubectl get nodes. I can see 3 worker nodes now: AKS node pool 1, AKS system node pool, and AKS user node pool. That means we are successfully able to scale down user node pool back to 1. Please note, you cannot scale down system node pool to 0 nodes. It always need minimum 1 running node, but you can scale down user node pool to 0. Let's verify that also. So what I'll do is I'll just scale it down further and I'll just make that as 0. We'll see if that works. The command seems to be successful. Now let's run kubectl get nodes. I can see there are 3 worker nodes running as part of this cluster: AKS-node pool 1, AKS-sys node pool, but I don't see user node pool. Let's verify that from the AKS blade. Let's hit on refresh. I can see there are 3 node pool attached: node pool 1, sys node pool, and user node pool. So user node pool still exists, but it is just that we don't have any worker node running as part of this node pool. That means we can scale down user node pool to 0. Let's try that for system node pool. Switch back to the terminal. This time I'm going to run the same command against node pool 1. It is failing, right? So I'm not able to scale down node pool 1 to 0. That's what I wanted to prove here. So we cannot scale down system node pool to 0 nodes. It always need minimum 1 running node in it. Now let's do one more thing. I'll just go back to AKS blade and we'll try to delete this node pool 1, which I get as a default with AKS provisioning. I'll just click on the node pool 1, and please remember this is where all my system ports are running currently. Let's verify that also from the terminal. I'll just go back once again to my terminal. We'll run kubectl get ports -n cube -system just to verify what all ports are running on what node. I'll just append -override to see the node name. So this port is running on this node. This port is running on this node, right? So likewise, we have other system ports running on corresponding nodes. The system ports are running on the node part of system node pools. So now let's go back to AKS Blade and let's try deleting this node pool 1. And remember, this is system node pool. Click on delete, say yes. So that will delete the system node pool, right? So let's close it and hit refresh to see whether the system node pool is deleted or not. It is showing me as deleting. Power state is running and node count it is showing as 0/0 ready. So it means worker node has been deleted already from the node pool. Let's verify that from the terminal. I'll just run the same command. All the ports are now running on AKS-sys node pool, right? So that means AKS-node pool 1 worker node has already been deleted and all the system ports are transitioned to AKS-sys node pool. Let's go back to the AKS blade once again, hit refresh. Now we can only see two node pool, sys node pool and user node pool. Now the final part of the demo is to convert user node pool into system node pool and system node pool into user node pool. Let's see that in action. I will go back to terminal. Let's clear the screen. And this is the command which I will run. Az AKS node pool update -g my resource group --cluster -name my AKS cluster -n user node pool --mode systems. So I'm just converting user node pool into system node pool. Let's verify that from AKS blade as well. I'll just hit refresh. It is showing me the provisioning status as updating. It will take a minute or so to update it. Hit on refresh once again. I can see the provisioning status is succeeded and 0/0 ready. Mode is now changed to system. Now my user node pool is converted into system node pool. Now let's convert user node pool back to user node pool. I'll just go back to terminal and we'll run the same command, but this time I'm going to change that system to user. Let's go back to AKS blade, hit refresh. You can see mode is already changed to user and provisioning status is updating. It will take another minute to change it. Let's hit on refresh. Now the provisioning state is succeeded, 0/0 ready and mode is already changed to user. Now we have two node pool, system node pool and user node pool. At this moment, if you try converting existing system pool, that is sys node pool, into user node pool, it will fail because we have to have at least one system pool running all the time for the AKS cluster. Let's verify that. I'll just head back to terminal and run this command. Az AKS node pool update -g my resource group --cluster -name my AKS cluster -n sys node pool --mode user. The command is already failed. It says message must define at least one system pool. So we have to have at least one system pool running for the AKS cluster, right? So that's it for this demo. We have seen manually scaling up and down of a user node pool, converting user node pool to system node pool, and converting system node pool to user node pool. In the next lecture, we will learn about automatic scaling in AKS. Thank you.